Well, today we are continuing our discussion of dimensional analysis that we started on Tuesday. And on Tuesday, we just kind of introduced it. We did some very simple dimensional analysis conversions, like between inches and feet and centimeters, things that you're already familiar with. And then we also introduced built-in conversions, like a per, if you were given something like a dosage or a density or a speed. When you have something per something, that per means divided by, right? And then we did a few. So we're going to do some more. That's all we're doing it today is dimensional analysis. So let's get started. Let's do following problem here. Oh, that's kind of small. Can you guys see that? I can make it bigger. Yeah, that's what I thought. Let's see. Oh, that's better. Oh, except I didn't get all of it. Let's try that one more time. There we go. Now can you see it? Excellent. Okay. Now here's our three-step method for dimensional analysis. Step 1 is identify the target units. Step 2, we're going to list all the conversion factors in the data that we know we have to use, that we know we have, or that we think we might have to use. And finally, step 3, we're going to analyze those units. So step 1, what are the target units we're looking for this problem? Perfect. Sarah's got it. Right here where it says how many milliliters, that's what you're looking for. Milliliters. Okay. Milliliters of what? We're looking for milliliters of the Roboxin solution, right? Okay. All right, step 2. We're going to list everything we've got. What did they give us? Yep, we know we've got 0.35 grams of Roboxin. You'll notice that I'm including both the measurement units of grams and the identity units of Roboxin here. Okay. And that's not equal to something. That's not a conversion factor. That's just a thing that they gave you. So it's just one piece. What else have we got? (100 milligrams per milliliter is the available concentration. And I'm going to write it like this. What that means is that 100 milligrams of Roboxin is equal to 1 milliliter of that solution. Does that make sense? Because I could call it 100 milligram per milliliter, or I could call it 1 milliliter per 100 milligram. They've given me, when they say 100 milligrams per milliliter, they've essentially given me a conversion factor, and I went back to the original equivalency, so I could choose, right? Excellent. Yep, that's what we've got. All right, are we going to need anything else here? Ooh, what else do we need? We need a gram to milligram conversion. Good, because on the top here I've got grams of Roboxin, and here I've got milligrams of Roboxin. Okay, so the one that I taught you guys, and you don't have to use this one if you've got another one you like better, but 1 gram is equal to 1 gram. And then I learned that milli is equal to times 10 raised to the negative third, right? So you can use this. If you prefer, you can use the conversion factor that there are 1,000 milligrams in 1 gram. That's the exact same conversion. That means the same thing, right? The top one says that a milligram is 1,000th of a gram, whereas the bottom one says there's 1,000 milligrams in a gram. Whichever one you prefer, you're good. All right, so now, step 3, we're gonna set this up. Analyze those units to set up the problem. So where should we start? Erica says, let's start with this milligram to gram conversion. Okay, what shall we put on top? Danielle says, let's put the grams on top. Okay, so 1 gram Roboxin in every 1,000 milligrams Roboxin. So I'm here, I've just kind of defaulted to this one, although I told you guys to use this one. You guys asked a really good question. Does it matter? What goes top or bottom? Does it matter? Which goes on top? How do you know? And there are some tricks to help, but the fact is, especially when you're first starting, it might not be obvious. And I don't want you to get caught up on it, right? I don't want you to sit here and stare at it thinking, I don't know where to start, so I'm not going to start. I just want you to start, because that's the beauty of dimensional analysis, is that if you put them in the quote unquote wrong place, the units will tell you. And the best part about it is when they do tell you, they'll tell you where to put them too. It'll solve itself if you're paying attention. Okay, so that's why I'm just like, it's okay, we'll just stick it there. Okay, so all right, we're starting here. We've got grams of Roboxin on top and milligrams of Roboxin on the bottom. So what are our target units again, and how could we get closer to them? What do you guys think we should do next? Okay, so Danielle says, let's use this one, 100 milligrams in a milliliter. Okay, perfect. So if I do that, I'm gonna put 100 milligrams Roboxin in the 1 milliliter solution. And I'm gonna, and I presume, Danielle, you did it that direction because the whole point of dimensional analysis is to analyze those units, and you can cancel that out, which is perfect. Excellent. Okay. What should we do next? Yeah, we got to do something to get rid of grams. What shall we do there? We're going to use, the 0.35 grams of Roboxin. We can use that to cancel out grams. Where should I put it? On the bottom. Let's put it on the bottom. Now remember, there doesn't need to be anything on the top because this is not an equivalency. It does not make a conversion factor. We just get to put it wherever we want it because we're the bosses of this stuff, okay? We're the bosses of these units. So we cancel out grams of Roboxin. Hooray. And now we have milliliters all by themselves. So is that going to give us the right answer? Danielle is right. It does not give us the right answer. Why doesn't it give us the right answer, Danielle? We're still doing dimensional analysis. We're analyzing the units. The units are supposed to tell us when we've done it right. And I got milliliters all by themselves, but I got milliliters on the bottom. And so when I do this math and I say 1 times 100 divided by 1,000 divided by 0.35, and I get a number of 0.286, and I'll just put this here, 0.286. That's not milliliters because milliliters are not on the top. That's per milliliters solution is the appropriate unit to report for this calculation. Do you guys see that? Because it's divided by milliliters, it's per milliliters. Or another way to say that, we would say 0.286 and then milliliters solution. Oops. On the bottom here. Right? Now again, I said, I don't want you to get caught up on where to get started because the units will tell you. And when you get to this point, I don't want you to say, oh, I did it all wrong, what a waste of time. Instead, I want you to look at this and say, oh, I did it 90% right, and I can see exactly what to do to fix it, and it's really easy. Can you see what to do to flip it, to fix it? Oh, I gave it away. You just flip it, right? You take the things that were on the bottom and you put them on the top. Like this. Do, 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 do. And so you don't have to feel like, oh, I did it wrong to start. No, you just did a different route with the flipping at the end. That's okay. There's no problem there. So now everything still cancels, right? The milligrams of Roboxin are still canceling with the milligrams of Roboxin. The grams of Roboxin are still canceling with the grams of Roboxin. And now we have milliliters of solution all by itself, which is what we wanted. And furthermore, more importantly, we've got it on top, right? So when I say we want milliliters, it has to be by itself and on top. Okay, so now we can plug this into our handy dandy calculator and say 1,000 divided by 1 times 1 divided by 100. Multiply that by 0.35. And this gives me 3.5 milliliters of solution. Does that make sense? Okay, it's Danielle's got a great question. She says, how would you know that you made the mistake? And the way you know is when you are paying attention to your units, and that's what this entire thing is about, right? When you're paying attention to the units, you would say, I've got my units for sure, and they're all alone, but they're on the bottom. They're underneath that dividing line. So they would be underneath the dividing line in my answer as well. Whereas here they're on top of that line, and so they would be, I mean, there's theoretically a line with an invisible one down here nobody cares about. That makes sense. So if you're watching that, right? Because we're saying, step one, this is my target units. All right, I got my target units, but they've got to be on top. Yeah. Yeah, unless my target units say specifically it's got to be divided by that one, right? It depends on the problem and what the unit they want where, and we'll do some more. But if they just want, unless there's like a dividing line here, right? Then it's got to be on top. Now there's another way to do this, by the way, without flipping the entire thing and going through the trouble. You can just take this answer and flip it and say 1 divided by 0.286. And you'd get the answer, 3.5, right? In fact, there's a button that will do it for you, right? So if I did 1 over 1,000 times 100 divided by 0.35, and I got here 0.286, this button, that 1 over x, will flip it for you. Oh, I'm upside down. Flip. All right, there's my answer, 3.5, right there. Okay. And yes, again, a question here in the discussion, how did we know some of this? And we pulled it right out of here and right out of here. And this one, you had to know your metric system prefixes. So that's when you have to know. That's when you have to know. Okay, if you got an answer that's really far off, then it's possible that your calculator is that you're doing something like 1 times 10 to the third or 1 times 10 to the negative third, but then you're not keeping it in parentheses. You're going to want to for sure keep that in parentheses. All right. And last thing before we move on, you could totally have done this problem by starting with the Roboxin right here, the 0.35 grams of Roboxin. I call that starting at the beginning. It's like, oh, I'm starting with this thing they gave me. Or you could have started it with this piece, right? To say, hey, I want milliliters. Let me just start with that on top and call it good. Any one of those would have been perfectly fine and appropriate, and would have had no problems there. You guys chose to start with here, and I thought it was a great way to illustrate how you can start anywhere you want, and you just need to keep your eyes open and pay attention to the units there. Okay, let's do another one. You ready? Okay, just gonna scroll down. All right, doctor prescribes Dramamine at a dosage of 1.25 milligrams per kilogram for a child who weighs, let's start at the beginning on this one. That's a great idea. For a child who weighs 43 pounds. So here we go. Doctor prescribes Dramamine, dosage of 1.25 milligrams per kilogram for a child who weighs 43 pounds. Comes in 50 milligram tablets. How many tablets should be taken? So number one, target units. What are my target units? It's tablets. This question, how many tablets should be taken? Right there. Tablets are the units that you're looking for. And it's fine if you got that question wrong. This is why I asked that question, right? Because it's really easy to not look carefully and not pay attention and miss that. So I want you guys to be careful about taking these steps. If it wasn't a problem that students ever had a problem with, then I wouldn't talk to you guys about it. All right, number two. What data do we have? What conversion factors can we use? What do we got? All right, we've got 1.25 milligrams, and I'm going to be specific about the identity units here. That's specifically 1.25 milligrams of Dramamine in every 1 kilogram of child, right? We did talk about this yesterday. When they give you dosing units, they don't tell you what they're talking about when they say milligrams per kilogram, but the drug, the medicine is always on top, and the person mass is always on bottom. So that conversion factor they gave us, 1.25 milligrams per kilogram, comes from this equivalency here. Good. And they tell us that we got 50 milligrams in every 1 tablet, so 50 milligrams of Dramamine specifically in every 1 tablet of Dramamine. Okay. And we did mention we've got a 43-pound child. Okay, anything else that we might need to do this conversion? Good question, Jessica. She notes that we're given pounds of a child, but we also need kilograms of a child. So we need some sort of conversion. And she asked, do we have to memorize pounds conversions? The answer is no. I will, if it's got any kind of English unit, I will give you a conversion factor. It might not be the most convenient conversion factor. So I might say that 1 pound is equal to 454 grams, for instance. And then you'd have to go through the extra trouble of going from grams to kilograms. So if you would like to memorize something, it might be helpful. You could memorize that 2.2 pounds is equal to 1 kilogram. This is one conversion factor that I tried to memorize for years, but I kept getting it wrong. I kept thinking that 1 pound was 2.2 kilograms, and it's not. It's the other way around. I don't know if it'll help you, but I'll tell you what finally made it click for me was, this is just silly, you know, the things that you do to help you remember things. 2.2 pounds is equal to 1 kilogram. And they are equal because they have, each side has the same number of syllables. There's 2.2 pounds, that's 4 syllables on the left-hand side, is equal to 4 syllables on the right-hand side for 1 kilogram. And that's how I know that the 2.2 goes with the pounds and not the kilograms. I don't know if that's silly, but that's how I remember that particular conversion factor that you don't actually have to memorize, but it wouldn't hurt you. Okay. All right. So I think we've got everything we need to here. And let's see here. Zachary said, let's start at the beginning. Let's do the beginning. So we're going to starting at the beginning. It's, let's see, probably this thing, that the thing that's not a conversion factor, right? The thing that would be converted away from. So we can start with that one. 43 pounds. Child, okay. What are we gonna do with that? It's a pretty good line for a while. Convert to kilograms, excellent. All right, so how am I gonna do that? One kilogram is 2.2 pounds. Okay, here we go. Pounds of child cancels. All right, now 1.2 milligrams of Dramamine over a 1 kilogram child. So we're going to use now this guy right here. Okay. All right, all right. Okay. And my kilogram of child cancels. And now I've got the milligrams of Dramamine that should be taken. What should we do next? One tablet of Dramamine contains 50 milligrams of Dramamine. Okay. Milligrams of Dramamine cancel. I'm left with tablets and they're on top. So I'm done. That looks good. That was the hard part. Now we do the easy part, right? 43 divided by 2.2 multiplied by 1.25 divided by 50, and I get 0.488. What am I supposed to tell that parent? Take a half tablet. Yeah, it'll be rare that you are exactly on, and that's why dosage guidelines are usually a range, right? So your dosage guideline might be between 1 and 1.5 milligrams per kilogram, and you kind of aim for the middle or on the lower end so that you're still within the therapeutic dosage, but not close to an unsafe dosage. Oh, yeah. Oh, sorry. So, in fact, you probably can't see that there. So I did 43, and then I divided that by 2.2 because this is on the bottom. And then I multiplied that by 1.25, and then I divided by 50 because that's on the bottom. I just ignored anything that's a 1 because if I multiply by 1 or divide by 1, it doesn't change the answer. You alternatively, if you prefer, you can also do 43 times 1.25, and then you can do 2.2 times 50, and you can then divide those two answers. Yeah, there's that. Okay, so the next question was, how do you know the best way for what unit to start with? That can be confusing. And the answer is that there's not necessarily a very best way. It can be useful to start at the beginning and kind of just move away from those units. I personally prefer starting at the end. So let's try that. If we started at the end, you might find this is useful. When you start at the end, you basically say, if I'm looking for tablets, I'm going to prioritize tablets. I'm just going to put that at the very beginning. I'm looking through here. I see, oh, there's tablets. I'm going to put that front and center so that I know it's always on top. That way you can kind of avoid the having to flip it, on tablet Dramamine. That, of course, carries with it 50 milligrams of Dramamine. And then you just spend the rest of the time navigating away from those extra units that came along, right? So you're like, I want the tablets, those make me happy, but I don't want the milligrams, those don't make me happy. So how do I get rid of milligrams of Dramamine? Oh, look, there's milligrams of Dramamine. I'll use this and say, I've got to put that on top so they'll cancel, right? So then I'll say 1.25 milligrams Dramamine in every 1 kilogram child, right here. And that works because it will cancel my milligrams of Dramamine. And then you can say, okay, well, great, but now I don't want kilograms of child, so how do I get rid of that? So then you look back here and you say, well, I've got a pound of child, but I need to get rid of that first. So I'm going to do a conversion to pounds here. So we'll say 1 kilogram of child on top is every 2.2 pounds child on the bottom. Oh, sorry, I didn't mean to change the colors on you. It's all right. Kilograms of child cancel, great, but now I'm left with pounds of child, which I don't want. So I just keep going, and then I see, aha, here's something. I can just plug that in. I don't need a thing on the bottom. I've got a 43 pounds child, and you'll see that those cancel, and it's essentially the exact same setup as we did above. It's just backwards, right? Here I started with 43 pounds, and I ended with 1 tablet per 50 milligrams. Here I started with 1 tablet for 50 milligrams, and then I ended with 43 pounds. It gives you exactly the same answer. Look, I'll show you. I'll start with 1 divided by 50, multiplied by 1.25, divided by 2.2, multiply that by 43, and I get 0.488. It's the same. So that's the one that makes the most sense to me. So that's what I do. That's what I like to do. Either one is perfectly fine. I'm never going to make you do it in a particular way, right? On the exam, the key is, did you get the right answer? And there's no point at where I'm going to judge the way that you got it. So Jessica says, can we start with whatever is easiest? Absolutely. You can start with whatever makes sense to start at the beginning. You can start at the end. If you are confused and don't know where to start, you can just pull out one of these conversion factors and slap it down and start converting, right? Because the worst case scenario, if you're watching your units and converting properly, the worst case scenario is you'll end up upside down. And you know how to fix that if you're watching and paying attention, right? The units are guiding you. They'll tell you what to do. Okay, shall we do another one? Or do you guys feel like you're pros? Okay, do another. More. Okay, so that is, I've done the 3 that were in the lecture notes. I did 1 yesterday, or 1 on Tuesday, and then I did 2 today that had to do with conversion factors. So now I'm going to move over to the worksheets, and I do recommend you're working through the lecture notes, then you move over to the worksheets. So just to show you what that looks like, here's your worksheet. And this was for chapter 1, and this is what we did. The first thing we did in chapter 1 is we did these conversions. We talked about metric conversions. We did some very simple dimensional analysis conversions, and now we've got a whole page of dosage style dimensional analysis questions, okay? All right, so we're gonna do, let's do some of these. Now these do move from easier to more difficult problems. So let's, okay. All right, let's move our 3-step method down so we can give ourselves some space to work. Okay. What are our target units? And if you're feeling confident, by the way, you can work a little bit ahead of us and then check to see if you're getting the same answer as we are. Okay, perfect. Our target units are tablets, okay? And specifically, our drug here is persantine. Okay, so we need tablets of persantine. Okay, I don't know how to pronounce that. Persantine? I don't know. Okay. Number 2, what do we know? What have we been given? Yeah, and this is not 100 milligrams. Persantine is not a conversion factor equivalency. It's just a thing that they give us. Okay, what else? 25 milligrams persantine. You see that per tablet? Yep, that's equal to 1 tablet. Okay, do we need anything else? No, I think we've got it, actually. Because we've got tablets. Oh, I should say that's a tablet of persantine. We've got tablets of persantine. We've got milligrams, and we can cancel milligrams. So this is good. Now, you may have you may have already looked at this and thought, okay, no, I know how to do this in my head. I don't actually need to use dimensional analysis. But the reason I start with, again, I start with ones that you can do in your head because I want you to practice using the method on ones that are simple. Because if you haven't practiced using the method, it's very uncomfortable, and it's just going to be easier if you're doing it with familiar things. So don't be dismissive and say, I could just do that in my head. I'm not going to use dimensional analysis for this. I'm not trying to show you that this is just a different way to do something you've already known how to do. No, I'm trying to introduce a new way that's going to be useful for much more difficult conversions later. So, all right, so follow me along. Where shall we start? Do you care? Danielle says 1 tablet because she wants to go backwards and just start with what we need at the end so she can be sure it's on top, right? 1 tablet per centene has 25 milligrams per centene. All right, and we can even we check that off, we used that, wouldn't want to use that again. I can help narrow it down. What shall we use next? Yeah, there's only one more thing to use. Should I put that on the top or should I put that on the bottom? Put that on the top. Why should I put that on the top? Because we want to cancel the milligrams per centene. Okay, that's perfect. That's exactly the right reason for doing that thing. So milligrams per centene cancel. We're left with tablets per centene, which is just what we wanted. So we're done. That's all we have to do. And I can do that on my calculator, but I'm not going to. 1 times 100 divided by 25 is going to be how many? Four. Yes. 4 tablets per centene. Does that make sense? It's perfect. All right. Yeah, but it's not going to stay that easy on the test. So let's do another one here. All right. But let's see here. Polysilane available as a solution containing 250 milligrams in every 5 milliliters. How many milliliters would you administer to give a dose of 400 milligrams of polysilane? Okay, so the question is, number 1, what are my target units? Perfect. Ooh, you guys are picking this up. Milliliters. How many milliliters? Yeah, milliliters of the per centene solution. Okay. All right. Number 2, what kind of data do they give us here? Yeah, our dose is 400 milligrams. You could say that equals 1 dose. We could just say that's the thing that they gave you. That's totally fine too. And they also gave you that you've got 250 milligrams per 5 milliliters. I'm always just going to convert that to an equivalency. 250 milligrams of polysilane equals 5 milliliters of the polysilane solution. Because I never know if I want to use that right side up or upside down. But sometimes I find if I leave it this direction, then it messes with my brain to turn it upside down. So if I put it into an equivalency, then I don't have that concern. All right, do I need anything else? I don't have a milliliter to milligram conversion other than this, right? This ends up being a milligram to milliliter conversion because it's the concentration of a solution, right? But it's not, we don't have like a density. So that wouldn't work. Okay, but I think we've got everything we need. Where shall we start? What would you like to do? $400 milligrams. Okay, excellent. And now what shall I do? All right, Jessica says, let's put 5 milliliters on top. and 250 milligrams of the percentine. On the bottom, percentine, oh, I'm still on last problem, polysilane. Okay, and now what do we do? Then what? Then we plug it in. Thank you, Sarah. I was trying to trick you guys into thinking that there was more, because that's a very common mistake to make. Just to like, I'm going to keep calculating until whatever. And this is why I give you, I'm like, no, identify those target units. And when you hit the target, you stop and you just say, I'm done. I'm going to plug it in. All right. So in this case, we've got 400 times 5 divided by 250. And that gives us an 8 milliliter of solution in our dose that we're going to administer. Just like that. Okay. This one seems just about as difficult as the last one because it's just a one-step conversion, but it has this extra, it does sometimes feel a little bit uncomfortable. We put this upside down, right? I gave you 250 milligrams per 5 milliliters. In order to solve this, you had to put the milliliters on top. Otherwise, you would have not gotten the right answer. So that's kind of trying to walk you through that, okay? And again, they do this in this worksheet, they do get more difficult the further you go. So, okay. Step 1, identify the target units. And again, if you're feeling confident, like get started early. See if you can do it faster than the rest of us. But what are my target units? Grams of glucose. Okay, excellent. Step 2, what have they given us? Got 5.5 liters blood, good. 85 milligrams of glucose in every 100 milliliters blood. Again, I took this milligrams per milliliter and I turned it into this equivalency here. I can use it however I like. What else am I going to need? I'm going to need milligrams to grams. So let's, this time let's do 1 milligram is equal to 1 times 10 raised to the -3 grams. Right? And we're going to need milliliters to liters. It's going to be the same conversion factor though, right? Because milli means the same thing, right? So 1 milliliter is equal to 1 times 10 raised to the -3 liters. Perfect. Anything else? Nope. Okay. All right, then what shall we start with? We're doing our conversion. 5.5 liters blood. Oh, Sarah wants to do blood. Danielle and Erica wants to do grams of glucose. Okay, hang on a second. And David wants to use the 85 milligrams per milliliter. Everybody wants to start in a different place. We can do it all 3 different ways. But let's see. Because I got 2 votes for grams of glucose, I'll start there. How's that? We can still do it the other ways as well. So grams of glucose are nowhere. So instead we're going to use this grams here to be our grams of glucose. 1 times 10 raised to the -3 grams of anything, including glucose, is going to be 1 milligram of glucose. Does that make sense? Why I did it that way? Okay. No. 1 yes and 2 no's. Okay, so several of you wanted to start with grams of glucose because, as we had talked about previously, that's our target unit. If I just put that there, then I can navigate away from it. But if I look at the things that are available, I don't have grams of glucose there. I do have milligrams of glucose there, which is probably why David wanted to start with this conversion factor. And the only other place I've got grams of anything is right here, okay? Now this conversion factor of 1 milligram equals 1 times 10 to the negative third grams, that's a universal conversion factor. It's for anything. 1 milligram of anything is 1 times 10 to the negative third grams of anything. So if I need grams of glucose, then I can steal that, yoink, and I can make it 1 times 10 to the negative third grams of glucose is equal to 1 milligram of glucose, right? And then I just move on from there. But if you guys feel like, whoa, that's too uncomfortable, then it's okay. We can backtrack and say, I wanted to start with grams of glucose, but that's weird. I'm just going to start with 5.5 liters of blood instead. We can do that as well. All right, another question you guys are saying, by saying that 1 milligram is equal to 1 times 10 to the negative third grams, yes, that is exactly the same as saying that 1 gram is equal to 1,000 milligrams, right? Those are the same. But I used that 1,000 milligram conversion earlier. I thought I would use this alternative one this time, just to make sure that we get kind of exposure to both ways. Did I confuse you guys too much? Go ahead, Danielle.
Okay, so the part that I'm missing on the top there is that it looks like to me that it's saying 1,000 milligrams is equal to 1 milligram. Does that make sense? That's just how I'm seeing it, but I don't understand why that's wrong.
You mean this thing that's in the box?
The top table thing that we started to work on, where it says 1 times 10 to the negative third. I'm reading that as 1,000 milligrams equals 1 milligram.
No. That is essentially saying 0.001 grams of glucose, right? Because it's times 10 to the negative third. If this was times 10 to the positive third, that would say 1,000 grams is equal to a milligram.
Oh, okay, that makes so much more sense. Thank you.
You're welcome. That was perfect. And anytime you want to ask a question, you could just unmute yourself, and that also works totally fine. So long as we're not all talking over each other, we'll be fine. Does it, yeah, that's the standard notation. Does this make more sense to you than this one? I think the reason that I used this times 10 to the negative third is because that's the way that I had taught you guys with the metric prefixes, and I wanted to make sure that you were familiar with this. So I've kept everything here, so I'm gonna scroll over. This was the table in our lecture notes of metric prefixes here. And so I encouraged you guys just to memorize milli is times 10 to the negative third. And so you could just say, if you couldn't remember what the conversion factor was, 1 gram is equal to 1 gram, and milli is equal to times 10 to the negative third. Therefore, 1 times 10 to the negative third grams is equal to 1 milligram. You can also put that in normal notation, 0.001 grams is equal to 1 milligram. Laura asked a question about on the exams, like, do you get this? Can you write it out? The answer is you don't get this table on the exams. You have to have it memorized. But just like you do when you take exams on class, it might be the first thing that you do when you hit start is that you sit down with your scratch paper and you do like a brain dump, right? You write down all the things that you remembered that you wanted to use, and you're going to write them down before you forget them. And that's allowed, right? But you wouldn't use this one from the lecture notes. You have to have it. You have to know it. It's got to be in your brain somewhere, even if you just do a brain dump and then use that on the exam. Does that make sense? Excellent. Okay. All right, we're going to do this both ways. Yeah, no problem. Both ways. But let's start with the 5.5 liters of blood. So now we have to get rid of blood because we don't even want blood. We just want glucose, right? So we've only got kind of 4 pieces here, but we've got to figure out what's going to be the way that will help us cancel out our liters and our blood. What should we do next? to get rid of the blood. Yeah, both of you, several of you have noticed that like, hey, I want to really use this because it's got blood. That's how I'm going to get rid of blood. But some of you guys have also noticed this has milliliters of blood. And so I can't actually put that there. And I mean, that would cancel out blood, but it wouldn't cancel out the liters. What I need to do is cancel out the liters. And this is the only place that I've got liters. Now, again, this is a universal conversion. It's not milliliters of anything. So liters, so I could, yeah, sorry, it is milliliters of anything is that many liters of that thing. So I'm just gonna call it blood for the purposes of this problem. And we can say that 1 milliliters of anything, including blood, is equal to 1 times 10 raised to the negative third liters of that thing, blood. Okay. This is exactly the same thing that I just did or tried to start to do with the glucose there. My liters of blood cancel. And I'm left with milliliters of blood. And then to go next, the next thing you guys wanted to do, right, was to get rid of the blood. You wanted to use this guy. So now we can use that. Where do I put the 100 milliliters of blood? It needs to go in the bottom so that they'll cancel. Excellent. So 85 milligrams of glucose in every 100 milliliters of blood. And I'm going to cancel milliliters of blood right here. Okay, so now we're at milligrams of glucose. Awesome. But I want grams of glucose. So what do I do next? Milligrams to grams. So again, this is a universal conversion. 1 milligram of anything is 1 times 10 to the negative third grams of that thing. And what do I want? What do I want where? I want the milligrams of glucose on the bottom so that they'll cancel, right? So I'm going to say 1 times 10 raised to the negative third grams of glucose in every 1 milligram of glucose. And then my milligrams of glucose cancel, and I'm left with grams of glucose. Okay, and then what do I do? Now what do? We have to stop, right? Chase was right. We're gonna plug and chug. Plug and chug meaning I just pull out my calculator and I plug in the numbers. I stopped because I got the units that I wanted, right? I'm at grams of glucose. If I keep adding in, I can, and that's, yeah. And this is the reason that we say first, number 1, identify your target units, because it's so, you have so many you can just keep converting. You can convert yourself in circles all day long. But if you don't know when to stop, it's going to be a little bit harder. Okay. And yeah, that's another, if you want to, it can be really helpful to say 5.5 liters blood. Okay, I used that one. There's no milliliters to liter conversion. I used that one. You don't have to use all of them, right? There may be a case where I give you more information than you need to solve the problem, right? But you wouldn't want to use the same one twice, or else you would kind of go in circles. All right, so we're going to say 5.5 liters of blood. Somebody here mentions, he's like, look, why plug these into my calculator when they just can cancel out? Why don't I just like cross those out, right? 1 times 10 to the negative third divided by 1 times 10 to the negative third. I think that's a great idea. Okay, so 5.5 liters multiplied by 85 divided by 100, and I get 4.68 grams, 4.7 grams of glucose. If that makes you uncomfortable to just cancel those out, I totally understand. Let's try it that way too. 5.5 liters divided by, you're going to want to use parentheses. 1 times 10, oh geez, this calculator. Don't use, well, I mean, you can't use your computer's calculator on the exam, but don't use a computer calculator on the exam because these are terrible. All right, 1 times 10 to the third negative, close parentheses. There we go. Multiply that by 85, divide that by 100, multiply that by 1 times 10 to the third negative equals 4.7 grams. All right, how do you feel about that? Once it's solved, it's not difficult to solve it another way, okay? So going back to the working backwards and saying, well, if I want grams of glucose, I'm going to start with the only place I've got grams here. And I'm just going to say, all right, well, I'm going to use this and I'm going to make it glucose. So 1 times 10 to the negative third grams of glucose on top, 1 milligram of glucose on the bottom. Now I need to get rid of the milligrams of glucose, right? Because I want just the grams. So the only other place that I see milligrams of glucose, right here, right? The 85 milligrams of glucose in 100 milliliters of blood. So I'll plug that in. And that does me the favor of canceling my milligrams of glucose, but now I'm left with milliliters of blood. And so I need a way to cancel that. The only place other place I've got milliliters is this one right here. So, and if it's got to be blood, it's got to be blood. Milliliters have got to go on the top, right? So 1 milliliter of anything, including blood, is 1 times 10 raised to the negative third liters of blood. And milliliters of blood cancel. What do I need to do next? Cancel the liters. So I'm going to pull over my 5.5 liters of blood here. And then we're done, right? Because now we've got grams of glucose by itself. Plug in the check, 0.001 times 85 divided by 100, divided by 1 times 10 to the negative third. Multiply that by 5.5. Wait, I'm off by 10. Oh, I divided by 1,000 here instead of dividing by 100. Okay, hang on. I did that wrong. Okay, so 0.001 times 85 divided by 100. Divided by 1 times 10 to the negative third. Multiply that by 5.5 equals the same number, 4.7 grams. Now David did it a completely different way, which was also totally fine, right? The name of the game is using these, kind of assembling them to cancel everything out except for grams of glucose. And he started not at the end with liters of blood and not with the beginning with grams of glucose, but rather with this conversion factor, because he knew he wanted the mass of glucose on top. So he just started with, hey, I've got 85 milligrams of glucose in every 100 milliliters of blood. And then he said, where do I go from there, right? Well, I need to get rid of my blood. So then he did the conversion between milliliters and liters there, right? He said milliliter. Actually, in this case, he did 1,000 milliliters is the same as 1 liter blood. Excellent. And then he did, so like this is totally valid. It worked perfect for him and I would recommend. Sounds great. And then he did the glucose conversion, right? Where he said, okay, well, I've got, for instance, 1 times 10 raised to the negative 3 grams glucose, and every 1 milligrams of glucose then you can come here, you can cancel your milliliters of blood, you can cancel milligrams of glucose. You've got your target unit right here, grams of glucose. You just got to get rid of liters of blood. So then you tack that on the end, 5.5 liters of blood. This might feel like a little bit more hodgepodge. Because what you're doing is you're canceling the liters of blood on the bottom with liters of blood on the top that are like 2 iterations over. You did the same thing here, cancel these milligrams of glucose on the bottom with this milligrams of glucose on the top all the way over here. But you can totally do that. Absolutely. Don't ever feel like if they're not next to one another, they won't cancel. Because again, this is that A times B times C is the same as A times C times B. You can do it any order you want. And if it's on the top and on the bottom, anywhere, it cancels. It's awesome, right? So that totally works. Okay. And if we plug this in, then we see we have 85 divided 100. Multiply that by 1,000. Multiply that by 1 times 10 to the negative third. Multiply that by 5.5, and we get the same answer, 4.7 grams. Okay, I've got a couple questions here I want to make sure that I get to before we do anything else. So one question said, if you're solving for tablets and you get a decimal point, what do you do? If it's really close to a real number, then like if that came out at 3.99, I would just say round to 4. If it's close to a whole number, I would round. If it's close to like, you would tell them a half. And if it was close to a quarter, you would tell them a quarter. In mastering chemistry, they don't want you to round. They want you to report the actual calculated value. So be careful with that. Also, I did have one student report to me, and this is totally true, in mastering chemistry, if your answer is a number that's less than 1, I'm not sure if you guys do this, but the proper way to say that is 0.488. So you would say 0.488 and you would not say 0.488. That sounds very nitpicky to you. It is very nitpicky. It's almost a grammatical thing that nobody ever taught you. I mean, nobody ever taught me. You're supposed to have 0 in front of the decimal point. That helps you know that the decimal point's there. So, by the way, mastering chemistry, there was one particular problem where it wouldn't even accept the answer because it didn't have the 0 there, even though it was the right answer otherwise. Yeah, it's really dumb. But there is that one. There is that one there. Sorry. Okay, there was another question about the metric prefixes over here. And they said, if you get a conversion that goes, this was Zachary, if you have to go from like milligrams to nanograms, can you just jump down or do you have to do it in order? Milli and then micro and then nano, do it in order. You can jump if you feel comfortable with that. And that would be to say, if I'm converting from 1 milligram to nanograms, I can see the difference is times 10 to the negative 6, or basically a million. And I can say, all right, well, there's a million nanograms in a milligram, because that's the difference between negative 3 and negative 9. The difference is 6. You can do that. I feel uncomfortable doing that. I feel like I will do it wrong. And so I don't do it that way. I do it a very slow and careful way, and I would go from milligrams all the way back up to grams. And then I would go from grams all the way back down to nanograms just to make sure I was doing it right. Right? So if I was converting from 1 milligram to nanograms, I would say 1 milligram, and then my conversion would say that every 1 gram has 1,000 milligrams. And then I would do another conversion saying that that there's 1 times 10 to the, that there's 1 nanogram is 1 times 10 raised to the negative 9th grams. And I would just do this dimensional analysis setup to convert. And I would go through grams because otherwise I would be concerned that I would not do it right. That's a really good question. Another question, any kind of online practice or videos I'd recommend? There's still some practice problems on the worksheet that you can go through. And actually, this is really easy, guys. Just Google, I did it right here. Google dosing, dimensional analysis, practice problems. And then you get a whole bunch of nursing practice problems. And if I run like a workshop on these kind of problems, this is my resource. And some of these are really helpful. So like here's this one, dosage calculation is the easy way. And she's going through level 1 dimensional analysis, piece of cake. And then level 2, dimensional analysis using multiple conversions, and she uses these kind of fun. Anyways, I like also that she uses some of this jargon that if you haven't been exposed to, it'll be helpful to be aware of, right? This Q 8 hours IV, okay, that means it's being administered by IV, and it's, for every 8 hours. I didn't Google it, I used DuckDuckGo, but dosing, dimensional analysis, practice problems. And number of videos, these can be really helpful, right? So this is just if you want extra problems, you can start with this, try to do it yourself, and then come back and see how she does it. But there's some really good ones, right? And here's some five-step conversions and so on and so forth. So it gets fun. Anyway, so this is you'll want to be able to do these. Again, there's like 3 questions on the exam that have to do with dimensional analysis with dosing, right? Because most of you guys are health science majors. I think once I teach you dimensional analysis, we should jump into something that feels useful, right? And not just be doing like length or mass practice problems. And so that's why I give you guys these ones. And hopefully that's why I test you on those. So hopefully also that hurts a little bit, right? If you get the wrong answer, I want you guys to realize like that patient could die. So that hopefully that gives you just a little bit more motivation to get the right answer. Okay, I'm gonna end this and let you guys go because we're a little bit over time. But I hope this has helped, and I hope you guys have a great day.